Hi there, this is the initial video in a series where we will examine the SD-WAN solutions provided by Teldat. The idea is to have a set of videos that are as manageable as possible, therefore as short, simple and basic as we can, to help illustrate each point of the tool. This first video will cover configuration, and we will attempt to create a setup from zero, ensuring it is as simple and basic as possible to keep the video concise and manageable. And following the diagram we have on the screen, where we will connect two remote points of a client using MPS network and the internet, we will focus on the points marked in red at the end, constructing a single virtual private network over these MPS and internet networks. We will employ tunnels over these networks to send the traffic from the client. To the right we would have what would be a data center with different IP networks, where let's assume there are several services that need to be accessed by remote locations. At this point in the data center, we will connect an M10 device with the specified addressing and connections I am indicating here. It will serve as a hub because we are going to make a configuration, as I said, as simple as possible. Based on hub and spoke, in an SD-WAN network by Teldat, there must always be a device that operates as the hub. Since it implements the control plane, there may be additional hub devices executing the control plane, and naturally SPOC devices will connect to the hub devices. This M10 device will function as the hub in this network, and on the left we have a device from a remote site. In this case, we will use an Atlas 60 to connect to this remote client site, which will naturally serve as SPOC using this connection and the addresses we have here, and to make the video more adaptable. What we are going to do is have the system automatically distribute the IP networks present in the LANs of the remote sites based on this C-class scheme we have here. Besides client traffic, there must always be management traffic, as I show here. The configuration of this network will be done from our SD-WAN controller, which is in the cloud as a service, therefore on the internet. What we are going to see in this video is the control panel screen of the SD-WAN controller. Thus, there will be two types of traffic in this network: client traffic from the left red network to the right red network, and on the other hand, management traffic directly to the internet from the devices. At the other points, 60 and M10. So let's start the configuration. Therefore, we will access the controller, and to do this we need to connect to this URL, teldat.clonemanager.com. And we access the Teldat management solution, where the SD-WAN controller is found. I will attempt to keep the scheme visible on screen for as long as I can, so we don't lose track of what we are doing. I won't cover all the platform's functionalities since the video would be too lengthy, but I would like to highlight a few things like this one. On the login screen, this button appears, and through this button, anyone can automatically create an account and generate a space in the multi-tenant for the configuration we will review here. I've already set that up, so I will log in using my account. And when we log in, the first thing we notice in the system are different options, different buttons. Each of these options, as you can see, represents a button, a functionality. This main screen has four sections: device, security, network, and analytics. We will go into the network part in this video, and in this network section, which is the configuration area, we will set up an SD-WAN network, so let's focus on this button, the BEAD SD-WAN controller. By clicking it, we enter this option, and the first thing we see is that here on the screen we can go back to the previous screen with this icon, and then we have these four sections here. Represented by these four icons, we are in the network configuration part, and within this network configuration part we are in the SD-WAN section, the first one, this one. Well, to configure an SD-WAN network, what needs to be done is walk through this menu. Well, we have the menu here on the left, or we have it here in the center. We can use either of them because it's the same. If you notice, they are the same options. Go from top to bottom. To begin with, upon entering a blank configuration, the only option available to us is the first one located at the top. And we are going to enter this option to start configuring parameters. Okay, here we have the global parameters option. These are all the global parameters we need to configure. And a little trick, if you try to save on any screen, it will tell you if there are any mandatory elements that are not configured, and they will appear in red, as you can see here. There are mandatory elements, but some are already pre-configured while others are not, so it will only mark those that are required and not pre-configured. Let's start with the first one, management network. The management network is the one I'm marking here, which is a network for assigning an internal address and a name, if you wish, to each device on the network. I will use this pool of addresses. This way I can register up to 256 devices on this network. Next is the overlay, the security section. We must set up the pre-shared key. We might also use certificates in this case. To keep it simple, we will use the pre-shared key, and what it is asking us for is the pre-shared key. It is not the data encryption key, but rather the key used to generate the data encryption keys. We only have DNS and NTP left. For DNS, we will configure a public Google's DNS this way. And for NTP, we will configure a public server as well, like this one. And now we have nothing in red. Now we can record. The remaining menu options are now unlocked, so let's proceed, as I mentioned, from top to bottom. Next, access provider. From here, what we need to configure, or what we need to handle in the SD-WAN Telnet configuration, are objects. There are various objects, sometimes nested. The goal is to get to the bottom of the menu and configure the devices, both for the remote site device and for the data center hub device. And here we finish the setup. We'll cover advanced settings in another video, but first let's complete all previous steps, because the template object uses the previous objects. Let's begin with the first one, the access provider. This object represents each wide area network, which in this case is MPLS Internet. Alright, let's get started. Set up these MPLS Internet objects using this new button. Let's start with the simplest one, the type called Internet. I will assign it a label. This is a label. Every object requires a label for referencing, so I will assign one. I won't overthink the labels. So I will label it Internet for when we want to use it or refer to the Internet network. And now we will create the second object, which in this case represents the MPLS network. So I will name it MPLS and specify that its type is MPLS. When we change the type, the system behaves differently. For example, in the case of MPLS, we would have the option that the user has to manually configure the MPLS addresses published by each device on the network. MPLS, or in such a way that the system itself distributes them. That distributes a network across all devices, which is the one I am highlighting here, MPLS private pool. Okay, I will configure this one, 172.16.2.0. This is because in MPLS networks, devices must always identify themselves in the MPLS network with dynamic routing using their own device address, which is what identifies it. That identifies it, which does not have to be the WAN address, as many times in MPLS networks it only makes local sense. So here we need to assign an address to identify the device as the next hop to the networks behind it. This is always necessary in MPLS networks. Another thing is whether we want native traffic over MPLS or just traffic through tunnels, but it is always necessary that in an MPLS network, to reach the device later, the device needs to identify itself. Thus, we need to provide it with a specific address, ensuring that every device listed in MPLS has an address that falls within this range. Alright, we have set up the access providers. The next step involves the services. Services refer to the various networks that exist behind the hubs. Here are the two networks we need to create. This is regardless of having one or several hubs and whether these networks are located in this or other data centers. Any network from a data center that is connected to a hub needs to be set up here. Thus, I need to set up the two networks I possess here. I won't make it complicated with names. I'll just use the same label as the network. I want to configure. I will configure these two networks here. I'm going to set up number 10 and using mask A like this. Well, I am setting up the services like this, the networks on the right side. The next point will be segments. Segments will be different VRFs that I can have in a network. In this case, it is very simple. It is all one single network. I possess a single VRF, which we will refer to as the red VRF, located on both the left and right sides. But I could have another network here, another VLAN with a network we can call yellow, and here as well. They could communicate yellow to yellow and red to red, but without mixing with each other. In other words, it means having distinct VRFs, even if there is some overlap among those VRFs. For instance, guest traffic, security traffic that differs from user traffic, and extra management traffic, among others. Let's keep it simple. We won't configure different VRFs. We will only use one, which is the default one provided by the system, which is the main segment, the main VRF. The next point is leaking, which is the connection between VRFs. In this case, it does not apply. Next object, hub groups. I previously stated that an SD-WAN Teldat configuration always requires at least one hub. Additionally, it also requires at least one group of hubs. Keep in mind that here it's only a label. Hubs from HQ. Next, we will check where this label is utilized, but for the moment we need to establish the label here. Now we proceed to the segments configuration area, or the configuration of the VRF, of the sole VRF we possess. Therefore, we have to define in this segment what user traffic is, what user traffic will exist, and which networks, what connectivity possibilities there are between networks, and how we want those networks to operate. Let's see it. We begin with the first item, user device groups. User device groups refer to the networks available on Xbox. Thus, we are defining this network here on the left, the 128.128. As always, we are going to label it. In this case, I will call it IP networks in remote locations to easily identify it. And here we need to register pools. I will set it to auto-manage the pools. As I stated earlier, the system locates addresses in the subnets of the locations, although we are only configuring one here. But if we have multiple, then the system could allocate the 122.128 one in the first site, the second one in the second site, etc. Now we need to configure the pool that must be located. This is a tag, but I will name it the same as the network which has to distribute here. I must provide the mask. Therefore, it has to distribute, as I said, the 192 or 168. That is enough. With this, the networks would already be defined. Local networks behind the Xboxes. The next point is traffic selection rules. We need to establish the traffic selection rule, which would be equivalent to a traditional ACL. Why? Because for each traffic we want to flow in this network, we must create an ACL, a traffic rule. So as always, hit new. New button, we give it a label. I'm going to call this one remote site traffic to data center, and here we have to tell it how to fit, what traffic needs to fit with this rule, and we could make a configuration based on here we have IP addresses. Here we have other SCP parameters, protocol ports, or even level 7 applications. Let's keep it simple. Remember that what I want is for the traffic to transit from this network to these networks. This was the network. Here we have. These are the networks on the left of the box, and in this case it has been called IP network in remote sites, which corresponded with the user device group I just created in the previous step, and on the other hand the services in the data center. So here I am going to select IP networks in the data center if there were. Configured several networks, as here I could tell you which of them this traffic selection rule is fitting into and which ones it is not. As here I want it to fit into all of them. IP networks in HQ included 172.24 and 10. So with this rule, with this ACL, we are already including all the traffic that can travel from left to right, from east to west. We save, and now we have an ACL. Now we group the ACLs into applications. In this case, it's a very simple network, so we are only going to group the only ACL we have created here. We select the ACLs, the traffic selection rules, the one we just created, and here we give the application a label. As I said, it is very simple. This configuration, but in a more complex network, we could have more rules here, some including traffic, others excluding traffic, similar to what is done with typical ACLs on a router. So we save, and now we have the application done. Now we need to tell each of those applications we have created, although we have only made one application, which traffic routing modes we want to assign to it. This is done here at this point. This is another object, so we are going to create traffic routing modes. Then we are going to create a traffic routing mode for the traffic. We are going to call it traffic, meaning remote HQs, and here I have the different possibilities. I am going to choose this one, or rather this one, for example. This one is better. Overlay multipath with SLA, which means sending through the tunnels, meaning the traffic that uses this traffic routing method will be sent through the tunnels, all of them at once, multipath, and also with SLA, which means that if the values I set here are not met on any of the paths, I leave jitter at 0 because I don't want to take it into account. If these values are not met, then during the time they are not met, that line is not used. In this way, this traffic mode will use both lines as long as those lines have no issues. I had mentioned at the beginning that besides the client traffic, red traffic, we have management traffic, so I also need to create a rule, an SLA, to send the management traffic. I'm going to call this one, if I previously called the other one remote HQ traffic, now I'm going to call this management traffic. I'm not going to complicate things here. Here I am going to tell you to send it through the underlay because that's what needs to be done, not through the tunnels but outside of them and without observing any type of SLA thresholds. This way I already have both possibilities for sending traffic. Yes, now what I need to do is combine the different traffic types with the traffic sending options, which is what is done in the policies. So we are going to create two policies, one for client traffic and another for management traffic. For client traffic, I will name it the same as I named the application before, remote site HQ traffic. I need to choose the traffic routing mode for the client's red networks. I will choose the one I created a moment ago, the remote site HQ traffic, the one that was overlay multipath, using all paths as long as they meet the configured SLA values. And here below I have to select the applications. I have only defined one, the traffic. This is the ACL for traffic between remote sites and HQ. I have already defined the first SD-WAN policy, and now I am going to create a new SD-WAN policy, but in this case for management traffic it would be the plus button. I give it the label management traffic. Here I choose the traffic routing mode that I configured a moment ago for management traffic. And here, in the case of management traffic, I don't need to create an application for it, but rather select the traffic from here. And here I specify which management traffic, the CNM traffic, that is the traffic with my SD-WAN control application, the DNS traffic including NTP traffic, SSH traffic, and for example Telnet traffic. So this way I identify that for these types of traffic this mode of transmission is used. Thus already I would have created the two possible policies, okay? This traffic management and the other one I created earlier, which is for client traffic. How to send it? Well, send it as defined in this SLA tag, which was overlay multipath. So this way we have already covered the most tedious part of configuration, which would be each of the client VRFs, what traffic is possible, and what we want to do with them. Okay, now we enter the part. Again, we return to the part of global elements. Then we enter the LAN Profiles section where we are going to configure this LAN profile. The LAN profile object for this remote site. Let's go there. LAN Profiles, by default there is none, so I click New, give it a label like remote site, okay? Because it's the LAN for the remote site. And what is this LAN like? Well, this LAN has to use the addressing I created earlier, 192.168, which I called IP networks in remote sites. Okay? And from this 192.168, what I want is for each remote site to create a subnet of 256 to distribute. So as I said, in the first network 192.168.1, in the next network 0.2, in the next 1.3, and so on. Here we could configure VLANs, VRP, other elements, and I'm going to leave it. I'm going to leave the addressing automatic via DHCP, so the system picks an address from the range I've assigned, and the rest for the machines that will be on the LAN. With this, we now have the local network configuration at the remote site, and now we're going to do the same for this cable. So, new button. This one is going to be a bit different. I'm going to call it HQ. And in this case, unlike the left side where it was a SPOC, a remote site, here it is a hub. So we need to specify that this is a LAN for a hub, therefore it's a LAN that will connect to services. These are the services I defined earlier. And in this case, in data center networks, it's always necessary to configure the IP address that the system has, the gateway, and logically the mask, which in this case is 255.254.0. It's a mask. 23. We are configuring this cable here. This address 122.118.26.1.43 with this mask and with this gateway, which is this one here. Moreover, being a service network, we have to tell it which segment these services belong to. Why? Well, because if we had multiple VRFs, it's important to say where we are reaching with this cable, with this LAN, which VRF it belongs to, and within that VRF, what services we allow to be seen and what services we don't. This is a fairly simple configuration, but in configurations with different VRFs, if within each VRF there are multiple IP networks, well, here we can work quite a bit with all of it and do a very granular filtering, even enabling NAT or not for access to the data center. Let's save. We already have the two local networks configured. To finally reach the templates, we only have the WAN profiles left. And here we need to configure for the two WAN profiles of the remote site and the two WAN profiles of the data center. Alright, let's start with the blue cable from the remote site. The internet access for the remote site. New button, we give it a name, remote site internet. We need to tell it which access provider, okay? The ones we have registered at this point, which were internet and MPLS. So we need to specify that it is of the internet type. Being of the internet type, it directly enables NAT for us. Next, we could specify if this interface will work with dynamic addressing, which is not our case. Okay, it's this blue cable, but it's static, so I have to configure it. Let's configure this network, okay, which corresponds to this point. It's the one I'm configuring, this clock. Let's go. We already have the first one. Now let's get the green cable from the remote site. Therefore, I'm going to call this one remote site MPLS. This corresponds to the MPLS network. In this case, I can enable or disable NAT as I wish. Normally in MPLS networks it is not enabled. I could define the BGP routing or not. And again, Since we're talking about static addressing, I have to remove the DHCP and configure the data here. 192, 168, 192, 62, 185, 255, 255, 255, 0, and 192, 62, 12. These are the data for the green line of this line. Okay. I already have half. I'm missing the other half, the concentrator part. So new button. We start just like before with the Internet 1. Let's label it Internet HQ. Tell it that it's from the Internet. Being from the Internet already enables NAT for us, and we have to configure the static routing from here as in other cases this is the address, and here the mask is 255, 255, 254.0. The rest of the fields are default, and we only have one left, which would be the MPLS line from HQ. MPLS, here being MPLS, it would remove the NAT. I could configure routing or not configure routing. In the case of VGP, other options can be configured through another path. And we configure the addresses. In this case, this is the address that this interface has, 255, 255, 254, 0, which corresponds to the MPLS line, therefore this point 142 with mask 23. Very well. With this we would have already set up everything necessary to create the templates, which is the ultimate goal of this configuration and this video. So let's create the two templates. We'll start with a template for remote sites. Here we need to set a console access password for the devices. These devices, when you want to access them via SSH or Telnet, we need to select the device. In this case, this device is an Atlas 60. We have it here. The configuration of this Atlas 60 is by default. Remember that we are configuring this device. It will behave like a Spock, and now this Spock device needs to connect to certain hubs. Which ones? To those in this group of hubs. For now there are none. Later we will include this, but for now we need to assign it to a group of hubs that this Spock needs to connect to. Next, the configuration of WAN lines. Here we have the remote site internet, remote site MPLS, which are the ones we need to use. So remote site internet, we see here that it is Ethernet 0/0. We look for it here and click on it. And we leave the default tunnel configuration. This will automatically create the necessary tunnels against the necessary hubs for that line. We are going to create a second line connection, which in this case is remote site MPLS. Remote site MPLS is Ethernet 0/1. Let's look for it. Here it is, Ethernet 0/1. Once again, we leave the default configuration. We already have all the ones created. So let's move on to the next point, which would be selecting VRFs. As we mentioned earlier, we only have one VRF, a single segment in this setup. Now the LAN part. So let's select it. We only have one, the LAN of the remote sites, because the system knows this is a Spock, as we have informed it. And there is only one LAN configured for Spock, which is the one we set up earlier, and it needs to assign an address from this range. So this is the one we need to select. And now we have to specify at which available points on the device we want the user to be able to connect elements of this LAN, of this network. And we have the last point of the configuration left, which is the most important, the routes. What traffic do we want to travel on this, in this device, since we have two. First, the management traffic. And what do we want to do with the management traffic? It is inherently already configured to go out through the underlay, but now we have to tell it through which line? So we have to tell it through the internet line. It is through the line that is reachable for the management traffic. And then the other traffic is the user traffic, the traffic from remote sites to the data center. And this is traffic that goes from left to right, east to west, if we remember that it is overlay multipath. Therefore it will be sent through the tunnels of all available paths, through the MPLS, through the internet. And we have to tell them which lines of the device. Let's not lose sight of the goal. We are setting up this device that has these two lines, and here it will give us the two options. We could tell them just one, or tell them both. This way, the client's traffic will be sent through both lines simultaneously to maximize the bandwidth the client can use for their traffic. What do we do with the rest of the traffic? Any traffic not configured here, tell the system to discard it directly. If we don't mark it, it would route it wherever a route is available within the overlay. But just in case, I prefer to discard it so that any other traffic, if someone connects a machine that is not from these networks, we will discard it. And done. With this we would have completed the first template, which was the goal of this video, and now we are going to make the second one, which is for the device. In charge of concentration, the M10. Let's get to it. New button. Let's give it a name. Let's call it HQ. It's the device we are going to install at HQ. Again, we need to set a password. For the device's management console, we have to select the model. In this case, this device is an M10 Smart OS DIC with default configuration. Role of this device. Remember, we are configuring a template for this device, therefore hub. Later, in other videos, we will see the possibility of hub in Spock to make more complex meshed, mesh, etc. configurations. Now we are going to set it up easily. This device will act as a hub, meaning it will only accept connections from the device on the left. And since it is a hub, we have to tell it which group. Notice that in this hub, we are specifying which group it participates in, while in the Spock, we were specifying which hub groups it belongs to. This information is what the system uses to create the tunnels. Well, I'm not going to explain the rest of the parameters. Let's configure the WAN networks. For example, here we are talking about the HQ, so the internet line would correspond to this cable here, which is Ethernet 1. So let's connect them here to Ethernet 1. Alright, and so we would continue. Segments, the main segment. We choose the LAN, which is the only one we have, HQ, because the system knows it's a hub, and the only LAN line created for hubs was the one we called HQ, and it must be connected to Ethernet 0. Here there is no switch, but rather independent ports. So we connect it to Ethernet 0, and finally this device, being a hub device, the only information we need to provide for management traffic is to tell it where to route the management traffic. We don't need to tell it here how to send traffic between remote sites and HQ. Okay? Because hubs learn. Okay? The traffic that the Spock send to the data center does need to be configured, but the return traffic is not necessary because hubs will always learn where to return traffic to maintain symmetry. Remember that we had said you could use both lines at the same time, since the hub will automatically learn through which line each of the different simultaneous flows is arriving and will respond through the same one to maintain symmetry. With this it would be done. I've missed a few things I'm realizing now. The first was in the routes. To mark this to route all the traffic. It's not very important, but I prefer to do things right and route all the traffic that I don't know what it might be. And I've realized there's something else I've missed. I've only configured one line. The one for the internet, the one below. I'm missing the one above. Let's configure it. It would be adding one. I select it. And in this case, the MPLS line goes to Ethernet 2. Here it is. Let's check that this goes to the Ethernet 2. Perfect. Well, we've already fixed that little mistake we made. And we now have the two templates configured, which was the goal of this video. In other videos, we will see how these templates are applied to 2 devices that we are going to install, and we will monitor that the tunnels come up, that traffic is sent, etc. Well, that's it for this first video.